Hi statisticians. In this lesson we're going to learn about the empirical rule and the standard normal curve. Let's get started. Today we're going to discuss intelligence testing. The first widely used intelligence test was developed by two psychologists in France. They called it the Binet-Simon IQ test, where IQ stands for intelligence quotient. In 1917, a group of American psychologists brought this test to the United States and used it on Europeans immigrating to the US through Ellis Island. Here's a table of their recorded results. As you can see here, they found that 83% of Jewish immigrants, 80% of Hungarian immigrants, 79% of Italian immigrants, and 87% of Russian immigrants were quote-unquote feeble-minded. And these proportions shown here are a subset they described as, in their determination, quote-unquote morons. And given the results of their testing, the authors concluded that, quote, one can hardly escape the conviction that the intelligence of the average third-class immigrant is low, and perhaps of moron grade. We also happen to know that these facts and figures are true today. Jews make up 3% of the US population and 0.2% of the world population. Yet, they make up 36% of the US Nobel Prize winners and 20% of all Nobel Prize winners across the world, 23% of Fields Medals in mathematics winners, and 16% of Ivy League students at universities like Harvard and Yale. So, we see an overrepresentation of people who were deemed morons in these metrics of intellectual achievement. And sure enough, these historical claims about intelligence have mostly been discredited, as most people think that these results were driven by differences in language, culture, and education rather than innate intelligence. Still today, IQ tests are still widely used, and that's because modern tests claim to have more validity than their older counterparts. Proponents of IQ tests include the authors of this book, The Bell Curve. It was published in 1994 and was a New York Times bestseller when it was released. The book analyzes data from a more modern IQ test, which claims to have validity as a measure of true intelligence. And they arrived at a controversial result, that there appeared to be racial differences in IQ levels. Now, let me be out front, and I personally believe that this is a flawed and frankly racist claim. As someone who has taught students of varying ethnic and racial backgrounds, I have never really seen a pattern in intellectual potential across these backgrounds. That said, this claim from the Bell Curve didn't prevent the book from becoming a bestseller. And these ideas are still discussed privately and even publicly on forums like podcasts, where Charles Murray, one of the authors, has been invited to continue discussing the Bell Curve. When we hear claims like this, one reaction is to reject them because we don't agree with their conclusions, but another is to investigate them statistically, to openly hear and analyze the evidence, and, if there are flaws, point them out when they arise. If we can expose the flaws as an incorrect claim, then we have a shot at convincing people that they are false. Otherwise, flawed ideas will live on. So, we are going to openly investigate the Bell Curve's claim today by answering this key question. Does IQ truly vary by race? With that question in mind, let's move on to our notes. We are going to cover two topics today, starting with the normal curve. This is a normal distribution, or as it's sometimes called, a bell curve. For a normal distribution, we see that the graph is symmetric and shaped like a bell. Now, according to the authors of the Bell Curve, IQ scores are normally distributed, so they can be approximately modeled as a normal curve, meaning that most people have an IQ score that is pretty close to 100, and only a few have intelligence that is far above or far below that. Because the normal distribution is symmetric, the mean is equal to its median, and both are located at the exact center of the curve. And the area under the curve is equal to 1, or 100%, meaning that the curve models all possible IQ scores. If we let X represent IQ distributed normally with a mean of 100 and a standard deviation of 15, this is what our random variable looks like. What would it look like if the standard deviation was only 5? Well, it would look like this. It's still a normal curve, but it would be a lot narrower on the same scale. As with all random variables, the area under the curve would still be equal to 1. So the smaller standard deviation means that the curve has to be taller and more concentrated around the mean. And when the standard deviation gets larger, going back to our original 15, the curve is shorter and less concentrated around its mean, as it distributes its probability more evenly across the wider interval of values. Now, let's discuss several properties of normal curves defined by something called the empirical rule. Every normal curve can be described by what's called the empirical rule, sometimes also called the 68-95-99.7 rule. This rule states that within one standard deviation of the mean, you will find 68% of the probability or data values described within the normal curve. So the majority of the data or probability lies within one standard deviation of the mean. Within two standard deviations of the mean, you'll find the vast majority, or 95% of the probability or data values. And within 3 standard deviations of the mean, you will find 99.7, or almost all of the probability or data values. Having a normal curve and applying the empirical rule, we can describe the data in pretty good detail. For example, assume IQ is normally distributed with a mean of 100 and a standard deviation of 15. What percent of test takers score at least 70 points? When presented with a normal curve problem like this, it is good practice to organize your work in 3 steps. First, draw and label the curve. Then, perform your calculations. Finally, answer the question in context. Let's see how that works. So, returning to our question, what percent of test takers score at least 70 points? We first draw the normal curve for the scenario. As you can see, we have labeled the parameters of mean of 100 and standard deviation of 15. We've drawn the curve with tick marks to show the scale and labeled the axis as our variable of IQ scores. The question asks what percent of test takers score at least 70 points. So we have found 70 on our curve. And we see the words at least. That means 70 is the least we can score. So we're going to use the proportion of IQ scores that are 70 or higher. So we shade that area upwards from 70. And labeling this in terms of our random variable, we're looking for the probability of capital X, the IQ scores, that is greater than or equal to 70. Now, from step 1, that's complete. We're going to go ahead now and calculate the probability. First, we note that 70 is 2 standard deviations below the mean. And by the empirical rule, we know that 95% of the area is within 2 standard deviations of the mean. So we can draw that in here. But it's not quite all of it. We also need this remaining upper section too. Since we already have 95% of the data within 2 standard deviation, outside of that is 5%. But we only need the upper half of that. So to find that value, we're going to divide that by 2, and the upper part is 2.5% in the upper tail. So adding together these pieces, 95 plus 2.5 is 97.5%. We have now completed part 2, the calculation. And finally, the third step, taking our answer and putting it in context. In this case, we can say that 97.5% of the test takers score at least 70 on the IQ test. Now, we are fully answering our original question. Let's look at another example. What IQ score is at the 84th percentile? First, we once again draw and label our normal curve. Now, note that this time we're not given an IQ score. Instead, we're given a percentile and we're being asked to find the IQ score. Recall that a percentile is a percent of data values that are at or below a certain point. So the 84th percentile means that 84% of the test takers will be at or below the IQ score that we're trying to find. As a probability statement, we can write that there's an 84% chance or 84% probability that our random variable, capital X, IQ score, is less than or equal to a certain unknown value, lowercase x. We have to find that unknown value, lowercase x. So on the graph, we can label the unknown x and draw the area and shade it in as 84% or the probability. Now that we've done the graphing and labeling, let's do the calculating. Recall that our curve is centered at 100. And below that center is 50% of the data. We're going to do 84 minus 50, and we have to find the remaining 34%. And recall that the empirical rule says that 68% of the data falls within 1 standard deviation of the mean. And conveniently enough, half of 68 is 34. So we know that 34% of the data will be one standard deviation above the mean. So we're looking at the upper 34%, 1 standard deviation above the mean. And we know that we must extend from the mean 1 standard deviation up. So 15 points higher than 100 or 115. So we can see that the 84th percentile is right at the score of 115. So our final step is to put that answer in context. So we would say that the IQ score of 115 is at the 84th percentile. Now, let's return to our question posed at the beginning of the lesson for our discussion today. We noted that the authors of the 1994 best-selling book, The Bell Curve, assumed that IQ is roughly distributed normally. And in the IQ data that they analyzed, they found that Black individuals tended to score about 1 standard deviation or 15 points lower than white individuals on average. To this day, some of the commenters use this result as evidence of racial differences in intelligence. So, this raises the question, where did the authors get their IQ data from? Well, they analyzed data from 1980, a year in which the National Longitudinal Survey of Youth had over 10,000 teenagers take the Armed Forces Qualification Test, or AFQT. Those scores on the AFQT were analyzed as IQ scores by the Bell Curve. And in their book, the authors of the Bell Curve claimed that, quote, the AFQT qualifies not just as an IQ test, but as one of the better ones psychometrically. To analyze this claim, let's look at the structure of the AFQT. In 1980, the AFQT had 4 parts: arithmetic reasoning, word knowledge, paragraph comprehension, and mathematics knowledge. Here's an example of a question from the word knowledge section of the AFQT. Take a moment to read through it. And here's an example of a question from the math knowledge section. Again, take a moment to read through it. So, with these items from the AFQT in mind, here are our discussion questions for today. First, A, do you think that the AFQT accurately measures intelligence? Why or why not? Then, building on your answer from part A, What might explain the racial differences found in the bell curve? Take a moment to jot down your initial thoughts to these questions, and we'll discuss them further in class. That's it for today's statisticians. We'll see you next time.